solving. It's actually Leetcode 200. So the question is actually asking for how do we find the number of islands there are given a 2D binary grid, basically a map. And the map actually have basically ones and zeros. One just simply represents a land, and zero just simply represents the sea. So what we're trying to do here is that we're trying to find the number of islands there are given a map. So you can see that based on the first example, there's actually only one island, because you could see that all the ones are actually connected together horizontally and vertically, and then the remaining cells are all actually zeros. So there is no other islands apart from one huge piece of island over at the first 3 rows and the first 4 columns. That's why the output is 1. So if you look at the second example, you can actually see that there are 3 islands clearly visually. So the first set is actually 4 ones that are connected together. The second one is one isolating one and right in the middle, and then the last one is at the corner of the map. So how do you do this question? One way is to visualize this whole grid as a graph problem. So I'll just do some drawings. So over here you can see the example of the second grid. One way we do it is we perform a depth first search, basically a search for the surrounding nodes that are connected to it in the depth first search manner. So when we're at the first cell, whenever we are at the first position of the cell, we will first find out whether the cell is actually a water or a land. So if it is 1, this means that it is a land. 0 just means it is water, and if it is a land, you will perform a depth first search. So perform DFS on land cells. So this is the key solution to the problem, and you stop the depth first search on water cells, right? And also you just simply skip cells that are already visited, so you don't have to check each and every cell more than once. So when you encounter a cell that is actually 1, what you would do is you will go and visit its neighboring cells, and you realize this is also 1, and you look at the neighbors. This is 0, you stop. The one below it is still 1, you continue, and now you reached a 0, you stop. You reach a 0, you stop. Now the last one is over here, you reach a 1, you continue. The one to the right of this node is already visited, you visit the one below and a 0, and you stop. And whenever you stop, this will represent an island. So what you will do next is that you will continue the search, right, for other islands. So when you reach a node that has already been visited, you just simply skip it, because you know that, oh, this is already part of the first island. Now your third node, this is already visited, do nothing. This is the 4th cell, but it's a 0, do nothing, do nothing. This is already visited, do nothing, do nothing, do nothing. And then you visit this cell, but it's a 0, do nothing. Visit this cell, do nothing. Then you simply just do nothing for the rest of the cell, and when you encounter 1, perform the depth first search again. So when you perform this depth first search on the neighboring cells, you realize they are actually zeros, and then the ones on the top and the ones on the left is already visited, so you do nothing. So you can just simply mark this as another island, and you continue processing. This is already done, so you skip it. Visit this, but it's a 0. Visit this, but it's 0, you do nothing. Visit this, it's 0, do nothing. So you visit this is already visited, do nothing. And now finally you reach one more cell that is 1, and you perform the depth first search again, and you realize you have a node that to the right of it is not yet visited, but it's also 1. So now you have all the cells already visited, and you will know that there are actually 3 islands. So this is how you actually get the output of 3, and that's the general idea of the algorithm, basically performing DFS on len cells and also counting the number of islands. So now we can go to the code and see how we actually solve it. So let's write code. Code count number given a grid. Okay, so the first step is having a dictionary that keeps track of the visited cell. So keep track of the visited cells. So we have visited, and you just simply have a dictionary to keep track of it. And what you would do is that for each of the key, you would just simply be I and J. That's just an example. So you just need to store the row and the column representation of the visited cell, and also you have the number of islands. So number of islands starts at 0, and basically this keep track of the number of islands to return this output. Okay, now we'll go through each and every single cell in the grid. So you can do this by finding the length of the row of the grid, the column length of the grid. This you have to put 0 because 0 just tells you the current row's length, which would then give you the column length. So next, first step is that we will only perform that first search if the node is not visited, right? So if I and J is not in visited, and the cell is a 1, which represents a length. So this way, we will be able to find out what are the neighboring nodes and how big the island is. Okay, so over here, perform DFS, giving I and J, giving the grid, and giving the nodes are visited. And when the depth first search ends, what you have to do is just increment the number of islands there are. So now we can write a function for DFS. In this case, we have the positions, we have the grid, we have a dictionary keeps track of visited cells. So next step is if the I, J is not visited. So if it's visited, sorry, you would just simply return it, right? Next, if the current cell is actually a water, what you would do is you would actually just simply add it to visited. You add it to visited. Just simply giving it true, and you just return. And then now you know that that cell is definitely a 1. You can just simply add that cell as well. If it's a 1, you just continue, and then the next step for this is that you would proceed on to the neighboring cells. So you have to first check if that cell that is above us basically is within bounds. So cell above us doesn't exceed 0, right? Because 0 is still greater than 0. You will perform DFS -1 J grid and then visit. So you have to perform this 4 times, right? Perform this 4 times, 1 for the cell above, 1 for the cell below, which is basically adding I, and then J, this is the cell to the left, -1 is to the left, and this would just be I, no change. This would be greater, smaller actually, the length of the grid. This will be j plus 1. So it should be lesser than the length of the grid. Okay. So first is that rows that are above you should not be smaller than 1. Rows that are below us should not exceed the row size of the grid. So you add 1 to it, grid 0, j minus 1 still greater than 0, j plus 1 still less than the grid size of the columns. So just need to make this adjustment here. Okay, so now you have the 4 parameters searching it, and now you can just simply return when you end the search. So we can actually test this method now. Printing out count number of islands, giving 2 different grids. First one is this to test. Second one is this. Okay, so you just give it a grid 1. And a grid 2. So the first one you're expecting 1 as output, 1 island as output, and the second one expecting 3 islands as output. So now let's try it. So you can see that there is a bug in our program. So it says that a maximum recursion, so there is recursion that never ends. Okay, let's see where the bug could be. So you therefore search visited. If I and j is n visited, means the cell has already been visited, you return. If the grid is equal to 0, you put it as visited, you return it. So first step, you have to make sure that the cell is a 1 and I, j not in visited. No, islands 1. Here you have to return islands. So let's see, grid visited. This cell's already visited, return. If grade is 0, you add. The position is true, return. Visited. Current position is true. Cell above us, which is -1, DFS -1, grid visited. Cell below you, sorry, this is supposed to be +1. So there's a bug here. In searching the cell below us, you add 1 to the index. It's not S, it's in. Okay. So now when you run this, you clearly see that there is 1 for the first output, for the first grid. You have 3 islands on the second one. So this is a very great question because it teaches about like recursion and also a lot of other things, because this is basically a question on how you can perform a graph search on a 2D array, and it is a foundation for many other problems. Yeah, so thank you.